Hey my friend, how are you? Welcome to Joystick. This is Joey, and in this video of Joystick, you are going to learn to solve the problem of finding maximum average value path in a 2D matrix. Now, this is another matrix problem that you are going to be adding to your pack of dynamic programming problems. If you are watching the videos of my channel regularly, then with every video you watch, you are adding something positive to your skills of solving computing problems. Now, let's take a look into the problem statement. So this problem is about a 2D matrix, hence the first statement begins with an n by n matrix given to you, and that is also filled with integers. Now your job is to travel inside this matrix from the top left corner of the matrix to the bottom right corner, but you have to travel along the path that gives you the maximum average value. Now there is a condition on how you can travel inside this matrix. Let's check that out first. Alright, so the condition says that you can either move down or in the right direction. It's that simple. So if you are starting from here, which is the top left corner, then you can either move to 3 or you can move down to 4. And same is the case which is going to be with every number over here. So if you are at 3, then you can either move to 4 or move to 5. You cannot go directly to 6. So this is the condition. Now this path shown over here is the path with maximum average value. The maximum average which is coming out is 5.8 because the sum of the numbers along this path is going to be 29. There are 5 numbers. 29 divided by 5 gives you 5.8. The other paths inside this matrix, which are not going to give you the maximum average value, but I am showing them to you just for the purpose of understanding, will be 1, then 3, then moving to 4, 6, 9. So this is going to be one of the paths. Or you can start from 1, move to 3, come down to 5, go to 6, and then come to 9. This is going to be another path. So these are the paths, and we are going to find out the path with the maximum average value and the maximum average value in our framework. But before we move to our framework, do subscribe to my channel and hit the bell icon if you haven't done it already, because that impacts my ability to make such videos for you in a direct manner. Now let's switch to the framework and solve this problem. To find the average, we need two components, the numerator and the denominator. Now, if we observe this problem matrix carefully, then we are going to realize that doesn't matter which path we follow from the top left corner to the bottom right corner, the number of elements that we are going to come across is going to be the same. Let's check the first path. So I start from 1, I go to 3, then 4, then 6, and then 9. How many elements I come across? It's 5. Now let's take another path. So I start from 1, come to 3, 5, then 6, and then 9. I'm again getting 5 elements. Okay, let's try a more twisted path. So I start from 1, I come at 4. I then move to 5, I then move to 8, and then 9. So again I come across 5 elements. That means I have to pass 5 elements on this path. So this proves that our denominator is fixed. And this is only possible when we are allowed to move only in the right direction, or we are allowed to move down. Alright, since we are not allowed to move left or go back, therefore it is working in our advantage that we are getting a fixed denominator, fixed number of elements along any path we take. So the point is that the denominator is fixed. So when the denominator is fixed, we only have to focus on the numerator, and the numerator is going to be the sum of the numbers along a path. So all we have to do is focus on finding the maximum sum, and automatically using the denominator which is fixed, we are going to find the maximum average value. So in this solution matrix, we are going to store the sum, and this final cell is going to give us the maximum sum, and backtracing from this cell, the bottom right corner, to the top left corner, we are going to find the path that is giving us the maximum sum. So you are going to understand it as we progress. So let's start filling this solution matrix. We are going to start from this cell first. So it's a no-brainer that the value in this first cell of the solution matrix is going to be 1. That means I'm taking this value, the value of the first cell in the problem matrix, and I'm putting it as it is in this cell of the solution matrix. Consider it as the base state or the base subproblem. Alright, now we move to this cell. Now to calculate the value of this cell of the solution matrix, we need to examine the same cell from the problem matrix. Now, how can we reach this cell? So we can reach this cell from only here because we are allowed to move right. Alright, so if we are here, we can come here. So when we come from here to here, what is the summation of the elements? So it's going to be 3 plus 1, which is 4. So why I added this 3 to this one? Because this cell holds the optimized solution of the previous subproblem, and we are using dynamic programming technique. Hence, we are going to utilize the optimized solution of the previous subproblems to calculate the value of the existing subproblem. Okay, now we come here. Now to calculate the value of this cell, we need to examine this cell. Now, how can we reach this cell? You have to ask this question to yourself. So we can reach this cell only from this cell because we are allowed to move right. So from here we can jump here. So what the value is going to be? It will be 4 plus this 4, which is going to give me 8. Okay. If you sum up these 3 elements, then you are going to get 8, and that is what we are doing, but we are using the dynamic programming technique. Now we come to this cell. Okay, so we can come to this cell only from this cell because we are allowed to move down. Okay, we cannot jump to this cell from either here or here because we are not allowed to move left, or we are not allowed to move diagonally downward. So we can only come to this cell from here. So what the sum of elements is going to be? And remember that we are calculating the sum of elements along every path to find out the maximum sum. So 4 plus 1 is going to give me 5. Okay. We move here. Now coming over here, there are 2 ways by which we can reach this cell. Here the actual problem has come out. So we can reach this cell from here because our condition says that we can move in the right direction, and we can come to this cell from here because the condition also says that we can move down. So there will be 2 candidates for this position, and since we have to find the maximum sum, we are going to pick the maximum value out of these 2. So what is the first candidate going to be? It will be 5 plus this 5. So first candidate is going to be 10. Okay, and the next candidate will be 5 plus this 4, which is 9. Okay, now it is so simple that the maximum value out of these 2 is 10. So I'm going to populate 10 over here, and 9 gets eliminated. Now we come to this cell. So at this cell we can reach from here as well as from here. So again there will be 2 candidates for this position, and we'll have to pick the maximum. So the first candidate will be 6 plus 10. Alright, so it will give me 16, and then the next candidate will be 6 plus 8, which is going to give me 14. So which is maximum? It is 16, and I am going to populate 16 over here. So when you are doing this DP problem on your own, I want you to expand each and every subproblem. By expanding, what I mean that whenever you calculate the value of a particular cell, you need to trace back and then you will understand it perfectly. Okay, moving on to this cell. Now we can reach this cell only from this cell which is immediately above it. There will be only one candidate for this cell, and it will be 7 plus 5. That is going to give me 12. Okay. Coming over here to calculate the value of this cell, let's examine this cell of the problem matrix. Again, there will be two candidates for this particular cell, because at this cell we can come from here or from here. So the first candidate will be 8 plus 12, which is going to give me 20. Okay. The second candidate will be 8 plus 10, and this is going to give me 18. Okay. Adding the current cell's value to the optimized solution of the previous sub problems. Remember, which is the maximum out of these two? 20. So I place 20 over here, 18 gets eliminated. Now the final cell. Now we can also reach this final cell from two cells. One from here, we are allowed to move right because, and one from here, we are allowed to move down. Okay, so the condition I am reiterating. So there will be two candidates again. The first candidate will be 9 plus 20, that is going to give me 29, and 9 plus 16, that is going to give me 25, which is the maximum. It is 29, so I'm going to populate 29 over here, and 29 is the maximum sum. So the average is going to become 29 divided by 5. That is going to give me 5.8 as the maximum average. Now let's find the path which is giving us this maximum average. So in order to find the path, the trick is simple. Now we are going to stand at the bottom right corner, and what is the value over here? It's 9. Subtract 9 from this 29. So it is going to give me 20. All right. So I have to check the value of the cells in the solution matrix which are immediately above and which are to the left of the current cell. Okay. So where is 20 out of these two? It's over here. All right. So this is my first step. All right. Now we are here at 20. What is the value over here? It is 8. So 8 subtracted from 20 is going to give me 12. Now out of these two cells, where is 12? It's over here. So this becomes my second step. So we are doing nothing magical over here. Whatever we did in order to calculate the value of these cells of solution matrix, we are just inversing that process. Okay. Now over here we have 7. So 7 subtracted from 12 is going to give us 5, and also there is no cell on the left, so obviously we are going to move up top. This is going to be my third step. Now I subtract 4 from 5, but if I consider this cell, there is no cell on its left. There is only a cell up top. So obviously we are going to move up top, and this is going to be the final step because we have reached the top left corner. So this is going to be the path which is giving us the maximum average value. Now let's check out its algorithm. So this is the algorithm dpij. dp is our solution matrix, and it's going to be equal to the maximum value between the value of the cell on the top and the value of the cell on the left, and the maximum value will be added to the same cell value from the problem matrix. That is going to give us the result of a particular cell of the solution matrix. While using this formula, you need to remember to modify it accordingly to facilitate the base cases. That means the value of the cells of the first row of the matrix and the first column of the matrix, as well as the first cell of the matrix. Otherwise your program will throw a runtime exception. So this is very generic. You need to modify this particular expression for border cases. Now finally the average is going to be dpn minus 1 n minus 1. That means the last cell divided by the denominator. The value of the denominator can be found out using this formula 2n minus 1. So this concludes this video. I hope you learned from this video. I hope you enjoyed watching this problem. I look forward to help you with algorithms and programming. Do let me know in the comments how you felt about this video. And only for this video, goodbye and take care.